Alright, ladies and gentlemen, here we go. Geometry 3-3, slopes of lines. Slope equals rise over run. M is the slope, it's dope, that's fun. Rise is the change in Y, subtract points 2 and 1, that's right. Run through the horizontal plane, that's a change in XT, hear what I'm saying. If there was a problem, yo, I'll solve it. Check out the book while teacher revolves it. Alright, ladies and gentlemen, that was this lesson in a nutshell. Here we go. Slope is the steepness of a line. That is rise over run. Also known as the change in y over the change in x, sometimes written as delta y over delta x. So if I want to find the slope, I read from left to right. J, I'm going to rise, count how much I'm rising, and that is 5. And then I count the run, count over, and that is 4. So my slope is 5 over 4. In this case, notice we're reading from left to right, so I have to start at L, and I'm going to count down this time. So that is -6, and then run is always to the right, so it's always a positive number. -6 over 3. So simplify that to -2. Slope of this line, to get from N to P, how much do I have to go up or down? None. So that is 0 up, 0 down. And then to get to P, the run here is 7. Well, 0 divided by 7 is still 0. This is a 0 slope. What about a vertical line? To get from Q to R, the rise here is 5, or from R to Q. However, the run is 0. You cannot divide by 0, so that is undefined. A vertical line is undefined. Now here we have a positive slope. Remember, we read from left to right. So if from left to right it's going up, it's positive. From left to right, if it's going down, it's negative. If you have a flat horizontal line, like y equals 3, for example, that's a 0 slope. A vertical line, for example, x equals -2, that is an undefined slope. Rate of change. We can use these words somewhat interchangeably, rate of change and slope. So the rate of change of a line. Here we have a pilot flies a plane from Columbus, Ohio to Orlando, Florida. After 0.5 hours, half an hour, the plane reaches its cruising altitude of 620 miles from Orlando. Half an hour later, the plane is 450 miles from Orlando. How far was the plane from Orlando 1.25 hours after takeoff? Well, we could graph this. Half an hour, or 0.5 hours, we're at 620. 1 hour, we're at 450. So the difference here is 170 within a half an hour. It's decreasing 170 from 620 to 450 in a half an hour. If I want to know in 1 hour, that's 340 miles in 1 hour. That is my rate of change. Okay, I want to know per 1 unit. And it's decreasing, so that's -340. If I want to apply this to 1.25 hours, well, we can use either one of these points, and then we can substitute the x variable, and we know the change in y over the change in x. Well, here my change in y, and this is a little confusing because we've used x here as our variable, but this is the y, y2, right? Always x and y. Sorry for the confusion there. So we're replacing that with a variable, and that's how I can solve this. Then I get -255 is x minus 620, add 620 to each side, and we get 365. What does this mean in the context of the problem? That means the plane was 365 miles from Orlando. All right, we've got a couple postulates that we're looking at, parallel and perpendicular lines. If you look at parallel lines, we've got line L and line M. Line L has a slope of 4, up 4 over 1. Line M has a slope of 4, up 4 over 1. So parallel lines, it's important that they're not vertical lines, because vertical lines don't have a slope. Parallel lines have the same slope. Okay? All vertical lines are parallel, but remember they don't have a slope. Perpendicular lines. If you look at line P here, it's perpendicular, and it has a slope of -1/4. Well, how does that relate to 4? We know that 1/4 is the inverse of 4. Negative would be the opposite, so it's the opposite inverse, or the negative inverse. So perpendicular lines have a negative inverse of each other, or the product of it is -1. So determine whether these are parallel, perpendicular, or neither. Well, here we have line AB. A is at 1 and 1, B is at -1 and -5. Okay, they look to be perpendicular, but let's find out. If I want to find the slope here from between A and B, that slope is 6 over 2, up 6 over 2, which is a slope of 3. The slope for line CD is down 1, that's -1, over 3, or -1/3. And 3 and -1/3 are opposite inverses, or negative reciprocals of each other, so those two are perpendicular. Graph the line that contains the point A, -3 and 0, and is perpendicular to this. So we know the slope of this line is going to be the negative reciprocal of the slope of this line. Here we have those points. We have A and we have CD. Let's find the slope of CD. Up 3 over 4. And then we need a slope perpendicular to that, which is -4 and 3. That means from A, I'm going to go down 4 and then over 3, and that's where I get my next point right there. And then I can graph that line. These two are perpendicular to each other. All right, and here's a little shortcut on how to find the slope. I call it the over-under method. Remember, y goes on top, change in y, over change in x. So change in y is on top, so I'm going to check to see, what do I have to do to 5 to get to 7? That's 2. What do I have to do to 2 to get to 3? Add 1, and there's my slope. Okay, now remember, key here is that you start with the y value and go over. Okay, so from 8 to get to 2, I have to subtract 6. From 4 to get to 2, I have to subtract 2. So my slope here is -6 over -2, and that can be simplified to 3. Here, over-under method, from 5 to -4, I have to subtract 9. From 1 to 1, I add and subtract nothing. That means we are dividing by 0, and you cannot do that. This is undefined. All right, and then here finally from 2 to get to 2, we don't have to add anything. And it doesn't matter what I divide 0 by. It's going to be 0, slope of 0. There you go. Quick tip on how to find the slope quickly and easily. And remember to like and subscribe to the Math2Mind channel.